Turn off mute there for a second. Thank you, Nikki. And it's a pleasure to be here. Always happy to talk with a group of aspiring engineers and people trying to make the water system better. Those are our goals at Sensus and Xylem as well, is we want to make water more safe, affordable, available, and make the operations associated with delivering those things efficient, cost-effective, and less risk associated with those activities. So I'll go over a few slides. We'll start at some high-level activities and then look at some constraints and uncontrollable forces on the water utility, some applied technologies from other industries that we're seeing creep into that water space, and then maybe the change of what the utilities need to look for in the future. And I'm very interested to hear of your questions, because I think that's the most interesting part for me, is to share other perspectives and get other information in there and really be challenged on some of those activities that we presented. So we'll go ahead and kind of slip through some of these things. The first thing I want to do is look at the overall picture of a water utility. So if you think about a water utility, they're responsible for delivering the water. And to put it in perspective, 1,000 gallons of water weighs over 8,000 pounds. That's 4 tons of water. And typically you're receiving that from $5 to $13, and they're taking away the dirty part of that. So for $5 to $13, you had 4 tons of material delivered clean and 4 tons of dirty material taken away. That's a monumental value proposition and an incredible efficiency to do that, because you wouldn't find that on the open market today. So, but there's lots of things in the transport layer: flow, pressure, level, water age, transients, acoustics, friction associated with the pipe. And a big part of that also is, hey, they have to do this, and they have operations and several functions on that: billing, sampling, testing, record keeping, flushing, reporting, hydrant testing, fire department use, planning, expansions, maintenance, repair, replacements, emergency management. So there's a lot of operations that have to take place to make sure that that water is delivered safely, cleanly, and effectively for us to consume or use. They also treat the water. So they have to treat it for, up on the screen is all the EPA requirements on drinking water, to look at microorganisms, turbidity, disinfectants, disinfection byproducts, inorganics, organics, radionuclides, the connectivity, the pH, ORP, algae, temperature, taste, and odor control. All those things are a function of clean public health and really customer satisfaction of making sure that water is nice, cool, clean, crisp when you drink it. And they have to respond to the ecosystem going around the wheel at the top there of weather, resources, service areas, topography, soil conditions. And in the middle are all the assets, literally millions, in some cases, billions of dollars worth of physical equipment that is buried or above ground, that needs to be operated effectively to do all these functions and react to the ecosystem, because we can't control the ecosystem. We just must react to them. And the reason the diagram is driven in a wheel with interconnectivity is, if you pull on any one segment too hard, you can potentially impact the other segments. And I often use the example of leaks. Leaks in the pipe serve actually 2 benefits to the utility. One is it's a stress relief for transients coming through the distribution network. If you fix that leak, great, you have some conservation savings, but you may also want to know where that transient force is going to the next, because it's looking for the next weakest pipe to create a new leak. And then you're just continually solving leakage location detection, as well as mitigation or repair, replace activities. And financially, you're no better off. The second benefit of leaks is they serve as an automatic flushing device. So if you fix the leaks, you're going to have a water age challenge that you may have to change your flushing parameters going forward to make sure that the human health is safe and consumable from disinfection to disinfection byproducts. So you can see the treatment and the transport and the operations are all tied together, and really they interact with those assets. And if you pull on one piece of the pie too hard, it's kind of like a spider web. It interacts with the others. Often that's lost in the greater data solution monitoring going forward. If we move on though, we want to make sure that it's focused on the whole water cycle. So the water utilities are not just focused on one aspect. They have divisions within them, but but really they have to manage it from the source water to the treatment, to maybe the export, maybe there's some groundwater storage on through the distribution system here. Maybe they have a combined sewer. They're certainly worried with stormwater in some capacity, whether it's a separate sanitary sewer or a combined sewer. They are managing that, and that's getting more and more constrained going forward. Onto the collection systems, the wastewater treatment, maybe some treated effluent, maybe even passing it back to reclaim going forward. So you want to make sure that the utilities are focused on actively monitoring all these operations, which is an enormous task. What is evolving now is the effective analytics associated with that and the proactive planning. If you have better data, you're not over designing or under designing of your water resources, your conservation, your sustainability going forward. And then dynamically optimize just the effectiveness of all the operations associated with it from a cost and revenue and risk standpoint, as well as customer service. So that's sort of the higher level overview. I wanted to give you guys a little bit of different perspective here on how we break down what's in that water system. So at the bottom of the stack here is the assets. And really that represents billions of dollars spent every year. About $35 billion in North America just goes for assets: pipe, treatment equipment, valves, fittings, equipment associated with operating those utilities. The next part is you put measurement on top of those assets to make them more effective, to monitor their operations, to increase their life, increase your efficiency, de-risk failure opportunities. And so things like meters and sensors, you see all the different types of sensors that might be in that piece. That's probably an abbreviated list. Certainly come up with more of those. Going up the stack though, after you've measured all that, you can operate that measurement with data loggers and log in and fetch the data. Maybe there's some low criticality or high latency things that are applicable for, but more and more people want to centralize that data and bring it together and use it for monitoring, as well as meter to cash, as well as effective planning and operations and analytics. So we see that monitoring layer is where a lot of spending is going on now. From there, you get to trending, where they're looking at parlaying multiple variables together to see the cause and effect of them, historical trends, such as relating usage or inflow and infiltration to weather patterns. And from the trending though, you get to show modeling, where you do scenario planning, long-term efficiency planning, resource planning, even emergency management scenarios. When you have something out of service in the water distribution system, you can create a hydraulic model, water quality model, stormwater model. You don't do that every day, but we're working towards solutions that would come up to that to make it near real time. And then lastly, you would have control. So we actually try to have either dedicated wired control or point-to-point telemetry on critical assets, where you could actually operate that independently of the monitoring and labor force. It automates that. Certainly not everything is right for control or modeling. That's why the pyramid gets smaller at the top. But most of the spending right now is in the bottom piece, and the impact to the utilities, the greater financial impact, is if you can utilize those assets more effectively to increase their longevity, their useful life, or de-risk their failure, or look at the consequence of failure versus the likelihood of failure. All that comes from the data to make them a much stronger, resilient utility going forward. So we all look at that. Then I want to talk about some of the financial, the drivers of social and economic drivers that a utility can't control. And there's quite a few of them here. And so population shift and expansion continues to drive towards urbanization, growth and more demand for water. The climate, it's hotter. That's certainly creating more volatile storms, more hurricanes, more 3-inch weather events, higher sea levels, saltwater intrusion into the aquifers. Agriculture, we have a need for more food production. That strains our scarcity in places, more demand for irrigation, depleting aquifers, as well as nutrient runoff from the aggregation that affects the water source. Human health, we're currently in a massive pandemic, and it won't be the last. And the water system fortunately isn't playing a large part in this one, but they have in the past with things like cholera, and outside of the United States, cleanliness versus health pandemics is a severe impact on the water system and a severe concern. What we do have in the United States that's unknown is all the microconstituents, the medicines people are taking and passing solubly through their bodies into the water system, wastewater, which goes into the next reservoir. So we're getting low dosage of medicines that were unattended that potentially have long-term human health contact. So that's going to strain the cleanliness and the treatment process going forward. Industrialization continues to expand. We see impacts of complex processes like PFAS are going to change the treatment opportunities going forward. It won't be the last, and it could have significant impact on spending in the next decade. Energy costs are running higher. To deliver water is an energy intensive exercise. And certainly energy is going to create more sourcing things and create more water challenges such as fracking to challenge the cleaning and processing of that water to make it safe for reuse. Infrastructure, we see a lot more regulations around lead and copper. That's going to constrain the funding and the spending associated with the water system over the next decade. It's something like a $30 billion price tag to fix all the lead and copper lines in the US. We see more infrastructure, more need for security on that infrastructure from terrorist attacks. And then lastly, the social and political climate. Citizens want more access, start smart city strategies from the mayors, and some fight between municipalities and privatization, which changes their operations and can cause stress. So what does that all mean? There are no new sources of water. All the water that's on the earth has been here since the dinosaurs and before. We can't manage the location of cost effectively or the phase. What we can control is the cleanliness and how we manage the operations of stormwater, wastewater, drinking water, collection, distribution going forward. So what does that mean for the water utility going forward? The impacts here, it's increasing demand in cities, more wastewater, saltwater intrusion, challenging stormwater, aquifer depletion, increased complexity of treatment, more demanding, more informed customers, higher energy costs, less money, more needs. Pretty undaunting gloom and doom story, but there's some positives. We'll get to those next. One more doom and gloom picture though is the financial picture of all these impacts of those social and economic pressures that cause bursting, aging infrastructure, non-revenue water, higher bills, water quality issues, emergency management problems, workforce aging, regulatory compliance, privatization, security, and funding. Financially, currently, it's looking rather unsustainable in a vicious cycle of downward spiral. What we have to balance that in the water utility is return on investment for the monies we do get, mitigating our risk because the risk causes huge financial consequences. Just think of the financial consequences associated with the water main burst. You're flooding businesses, you're interrupting traffic, you got water contamination problems, you got supply issues, fire supply concerns. So if you can eliminate some of those bursts in a year, it can have a huge financial impact to utilities. Asset utilization, just more effectiveness on this millions and millions of dollars worth of assets. If you can get them to work better or extend their life, that's big savings. Public perception, if we can show that we're improving that, maybe that's some rate alleviation. It's coupled with customer service. And then lastly, just overall efficiency. If we look at some of the good side of what's coming though, some of the technologies available in other industries that we can play into the water space. Electronics, having more edge capacity, batteries, longer life, cheaper prices. Communications, there's more infrastructure, higher bandwidth. Data storage, Amazon and Google have made that incredibly cheap. So it's more accessible, more affordable. Analytics, you got a huge burgeoning team such as yourselves that are more data scientists, more analytics, more software associated with that. So it can all lead to more sensors, more data, more transparency, more affordability, more options, more resources, all creating new paradigms, new relationships, and new opportunities in the water space. We want to bring that technology in there to balance some of those stresses that we talked about before. So what happens? What does the utility need to be? going forward. They need to be resilient, multifaceted approaches, redundant, responsive, diverse skill sets, deeper understanding, more sustainable across the water cycle, more efficient in transport, treatment, time of use. The water supply at 7 a.m. versus 2 a.m. is quite different. If we can level some of those curves, we can affect our energy impacts as well as quality, more usage of the data analytics, more transparency, more data availability, interconnectability, notifications. If we don't get the data to the guy in the field, almost every solution in the water utility typically involves a wrench, a person, a shovel, a piece of equipment to make the improvement happen. We have to get the information out to the field effectively, efficiently, and timely. And then accountability to, did you get the return on investment going forward? So all that also coupled with managing risks and public safety is a primary concern for the water utilities, but they must adopt some of these principles going forward. So that's sort of the overview, Arching. We have a few comments coming in, Nikki, that I'll try to address in the chat room in the order they came in. The first question was, as I see it here, does Xylem work closely with communities on the local level? Absolutely. So we have numerous salespeople out there to help them get the right equipment, the right solution for the problems they have today, and probably the problems they have tomorrow, looking at a prioritization, because almost no utility can afford to invest in a solution for everything at one time. They have to kind of prioritize that in a level of criticality and return on investment. So you get some return on investment at one step to pay for the next step. We encourage, if you can't find a Xylem guy at your utility, you can reach out to me and I'll put you in connectivity with them. A second question, is there a specific level of leakage that you recommend in water utilities? In drought prone regions, any leakage seems quite wasteful. Could you expand on this? That's a great question. So the average leakage in percentage, and they don't like to talk about percentage because the leakage is typically constant pressure. And so the leakage percentage in the winter is much higher than in the summer. But to put it in context, the average US utility has about 24% non-revenue water. That's broken down probably into 15% leakage and 9% in self-usage. A good measuring stick is 9 or 10% leakage in your system. Some utilities are able to get down to 5, but there's a lot of leaks that are really small. A quarter gallon per minute leak on a doesn't often justify the hundreds of thousands of dollars to repair that leak, much less locate it. So there's an economics between the size of the leak and the repair costs versus the cost of the water. So it's a great question. There's always going to be some leakage, and the AWWA has huge information on the M36 manual on water loss control. I would refer you to that for additional information on all the metrics associated with water loss, but a great point. Next question, how are the water utility assets adapting to their changing ecosystems? How do you close the loop with the end users? Great question. So they're trying to figure it out. Most conventionally, it's to get more information about what's going on. Until recently, batteries and electronics weren't affordable to put out there in the utility to get lots of data information. But that has changed now, because previously you would have had to run power to everything to get data and comments. But it can be done with batteries and putting up a lot of information. We see huge gains in pressure management and the leakage associated with that. The cheapest way to fix a leak is actually to reduce the pressure on the system, because you don't have to use a shovel to do it. If you can reduce it from 65 to 60 psi, you can have on all the leaks in all the systems if it's available. Next question, can you expand a bit on Xylem's use of scenario planning? I'm not understand all the context of the question, but we want to help utilities on the problems they have today and offer them flexible and solutions so that the assets they buy today can grow and be utilized for future concerns. You know, the common place to start is often in the hydraulics realm, but you don't want to leave water quality alone. So you want to make sure your comm solutions and your measurement strategies can incorporate both hydraulics information and water quality information. And you want to look at your data piece to to look at how are we integrating those things together? Are we getting the data out to the field? Are we working with the asset management system, the GIS system, as well as the work order system to make that data actionable out into the water utility? So a great question. Hopefully I answered it. If I didn't, ping me again in the chat or call me later and I'll try to expand. Is there a specific level of leakage you heard? I think we covered that one. Let's see, Peter Gross, how do you see the medical silo and energy silo merging with the water silo? So great question. I'll address the energy first. Water consumes about 3% of the United States power and energy consumption. So it's not insignificant as one single entity. It's not monumental. Most of it is done in pumping, both in collection and distribution. The other big piece is in the aeration of the wastewater treatment. I think that as energy costs arise, that you'll see utilities find other ways to stratify their energy usage, either through solar power or biosolids, bioenergy usage, because they have an enormous source there of bioenergy right there at the wastewater plants to mitigate some of that use. We've seen Little Rock, Arkansas now has a 50% of their own power supply comes from bioenergy at their wastewater plants. So they're leading the US. In Europe, there's one energy neutral wastewater plant that I'm aware of. I think that will continue to evolve and be a concern. I think the hydraulics modeling will reduce the energy consumption throughout the entire distribution system because we'll be more effective on pressure, time of use, and rate times. The medical thing is interesting because I think it'll take a long time to prove that low dosage chronic health or medicine dosage through the water system causes specific health problems. So it'll take a long time and probably some severe consequences like Flint, Michigan before we take political action on that, but it's certainly a growing problem. That's all the questions we have, Nikki, and I think I've run out of time.
Thank you, though. That was very good. And those are great questions. So thank you for answering them.
Yeah,
great presentation.
My email's on the screen.
We will definitely share your contact information. So if anyone has any follow-up questions, please feel free to reach out. It's been a very open and great presentation so far. So I hope that we can continue having an open discussion after.
Sure. Thank you for the time, guys. And I hope I shared some stuff that gave you some new perspective. You guys certainly had some good questions. Thank you.
Take care.
Bye.
So I would like to say thank you to everyone who joined us today. Tomorrow, our panels will be focused on resilience in the water, energy, food nexus, highlighting the trade-offs in the effective management of water and energy, food security, and equality. Tomorrow, we will also have our kickoff event for the Water Innovation Prize. And in case you didn't know, the MIT Water Innovation Prize is a startup competition focused on water innovation that awards up to $35,000 in innovation grants annually to student-led teams from across the country and internationally, sorry. This kickoff event will happen at 4 p.m. tomorrow on Zoom. If you're interested in attending, please register at the mitwaterinnovation.org website, and I'll put that link in the chat in just a second. At this time, we're going to start our virtual networking session on Zoom at the link sent in the chat once I'm finished. It's accessible on the online event page as well. We encourage you to sign off of this webinar and join the networking session. It's going to start as soon as we close this webinar. If you can't make it, we'll see you tomorrow. We start at 10 a.m. Eastern Standard Time. For those of you staying for the virtual networking, feel free to take a break, but we will open the Zoom room right away. So thank you, and we look forward to seeing you in networking. I'll put the links in the chat. This link is for the Innovation Prize. And here is the virtual networking link.